The countdown has started. Good morning, everyone. Thank you for waking up early and coming to these talks. Recently, I've had the opportunity to work with a few ZK rollups and ZK bridges who have been building on AWS. And a lot of these projects require fairly large instances, so maybe dozens of CPUs, lots of RAM, all that stuff. And a common question which comes up is, how do I reduce the cost of this? And so what I want to share today is one way that we designed for reducing the cost of running your ZKPs on AWS. My name is Emile Baizel. I'm a blockchain architect at AWS, so let's get started. And that's me. Okay, so today we're going to start with an overview of EC2, which is our elastic cloud compute. If you've ever spun up an instance on AWS, you've used EC2. I'm going to talk about the different ways that you can that we price out EC2. And then we're going to get into some more of the details around spare capacity of EC2, which is what we call spot. And that's really the underlying thing which we're going to use here for cost optimizing our ZKPs. And then we're going to do a bit more technical deep dive into specifically what you need to do to run ZKPs, because there are some nuances with running on spot versus running on that. And then we're going to end with a bonus, untried, untested, theoretical thing around serverless ZKPs, and this is something which came out from a discussion I had with one of those projects. So let's talk about EC2. As everyone here knows, depending on the type of application that you're running, if you're running a website, if you're running machine learning or DNA sequencing, you need very different types of compute requirements, right? And that's why we have many different categories of compute. There's compute CPU intensive, memory intensive, stuff that has instant storage versus network storage, so a lot of different kinds, and we're adding to this quite a bit, and so there's over 600 different instances. And if you're wondering why does this matter with Spot, the reason why this matters is one of the key ways of being successful with Spot is being very flexible in the instances which you run, right? So having flexibility in which instances you can run your ZKP on is going to improve your opportunities for running on Spot. Okay, so let's talk about the purchase options. So on the left, you've got on-demand instances. So if you've ever spun up an instance from the AWS console, you click Start, more than likely, you've gone with on-demand. And with this one, you get billed by the second. So if you run it for 2 minutes, you get billed for 120 seconds. You shut it down, you stop billing. And this is good for sort of spiky workloads, if you need something to run for a bit of time and then shut it down. But if you're going to run something that's long running, if you're going to run a website and you know it's going to be running for a long time, you're better off doing a savings plan, because you can commit to 1 year or 3 years, and so you get a reduced cost there. And the last one is the one which we're going to spend the rest of the talk on, is Spot instances. And with Spot, you're basically taking advantage of spare computing capacity on EC2 to get up to 90% discount. And that's where the cost savings comes in here. But there are some constraints here. And so Spot is really optimal for stateless and flexible and fault-tolerant workloads. And I'll get into the fault-tolerant piece here in a second. Okay, so let's see how this works. So as an example here, we've got several different instance types, and we're going to look at one of the instance types here, the C6i12x large. It doesn't really matter what the instance type is. This is just for one. And when we talk about elastic, what do we actually mean by that? So as AWS, we want to always be able to offer instances on demand. So when a user says, hey, I want to spin up a C6i12x large instance, we want to be able to provide that. So in order to be able to provide that, we always have spare capacity ready to go to provision. Now, what we see in this picture is a stack of C6i12x large instances, and this is just a figurative representation, but the red boxes here are the ones which are currently being used. The white ones are spare capacity, and we call this the Spot pool. So you come in and say, hey, I actually want to spin up a Spot instance of this, and so now you have a Spot instance of the 12x large here. And this one comes at a very steep discount compared to what is if you're running there. So that's how Spot works. And underneath it, you're using the exact same hardware, the same infrastructure, as if you were going through on-demand. Everything is the same. It's just the pricing and how we price it, which is different. We talked about the pricing. You get up to 90% discount on this. Interruptions, we haven't talked about this. So this is something that is different about Spot. So because we want to be able to serve customers that request this on demand, we need to be able to reclaim the Spot instances when capacity dries up, the spare capacity. And I'll get into interruptions more in a second. And then diversification, we talked about this a bit, but being able to be flexible in the workload which you have. I don't know what is that stuff on there. Okay, so interruptions. So let's say you're running Spot, and then EC2 says, we actually need to reclaim that because there is a surge in the demand for the on-demand instance. So there's two ways of reclaiming. The first is proactive, and this is the recommended one. And proactive is basically a warning that you receive on your instance that says demand is rising for this instance, and there's an elevated risk that your instance might be reclaimed. So this gives you an opportunity to do anything you need to do to prepare for that and then wind that instance down. Or there's a reactive, which basically gives you a 2-minute warning that says your instance is about to shut down in 2 minutes, and then you need to take any actions there. So ideally, what you can do in that 2-minute warning or in that proactive warning is save any state which you've already generated in your proof so that the next time the Spot spins up, you haven't lost all that compute which you've done there. So your proof generation needs to be able to pick up from that state. Otherwise, you're just going to have to restart from everything else. A bit about diversification. This comes in a few different areas. So the first is instance type and instance size. So rather than saying I want a C6i 12XL, you can maybe say I need at least 48 CPU and at least 1 terabyte of memory. And then whenever an instance is available that matches those requirements, you will get matched. So being flexible in which one works will give you a lot better opportunities. If you don't have any restrictions or requirements on geography and where that runs, that's going to increase your opportunity as well. So regions and availability zones, and then being flexible on time. So if you don't need it this instance and you can wait, minute or hour or something like that, that helps. Okay, so now we know about Spot, how all that works. Let's see how you build ZKPs on Spot. Okay, so on the left, at the bottom here, you've got an Amazon machine image. So when you spin up an instance, whether it's on demand, Spot, anything, it loads an Amazon machine image, will load up your base system. And that pretty much is your operating system. We keep it very, very lightweight because we don't want to bloat it, and we don't want to add additional libraries, which you may or may not need, which introduces additional security threats and things like that. So we keep it very minimal. But any application you're running, whether it's a web app, whether it's a ZKP, you're going to need utilities on top of that, right? You need your Git compiler or your Git command line. You need some compilers. Maybe you need to build a compiler. Maybe you need to install a package manager. So all this stuff adds time, right? And on top of that, if you're building a snark and you've got a huge circuit, you're going to have a several gigabyte proving key, which you're going to have to download to your instance. Now, if you're running an on-demand instance that's always available, this is fine. It's a one-time hit that you're going to take. Maybe you can wait 10, 20 minutes, however long it takes, and you're okay with that. But if you're doing this on Spot, and your instance is going to wind up, run, and then wind down, and then wind up, and you're going to take that hit every single time. And so what you can do is set it up one time, take a snapshot, and create your own AMI. Now, the next time your instance spins up, again, whether it's on demand, whether it's Spot, you're going to start from this point. So right away, all you need to do is download any data that you need for generating the proof, and then you can get going there. So this in itself is going to save you a lot of time in the proof generation there. So some considerations with Spot. As we talked about, must be interruption tolerant. So being able to respond to that warning that your instance is about to be reclaimed, and ideally persisting state somewhere else. So then when the Spot instance recovers, or when you come back online again, it can pick up from where that is. The second one, this came from one of the ZK rollups where they were saying, depending on mainnet pricing, they may hold off pushing state onto mainnet for hours because the cost of pushing that state onto mainnet is so expensive. And hopefully, and it's going to go down with 4844. So hopefully that makes this less of an issue. But they're already coordinating with mainnet pricing. So having to coordinate with spot pricing may introduce an additional complexity, or it's something which needs to be designed around. So for example, if you're generating your proofs and then you just have them ready to go whenever mainnet pricing is available. The other thing is not all instances are available as spot. So again, this comes back to flexibility, being able to be flexible on which instances you're running, and not every instance is available in every region as well. And the last one is something that came out from one of the ZK bridges, which I was talking to. They want to continually or periodically on a consistent basis send state from mainnet to another blockchain. And so this is something that they don't want to depend on spot, because if spot pricing is too high for a while, then they're going to have a long period where they're not pushing state. So for them, having a baseline capacity makes a lot of sense, right? So taking a reserved instance where you're getting a lowered price for committing to like a year or 3 years makes a lot of sense. But on top of that, applications can request proofs on demand, right? So if there's a trade or if there's something else where an application on the destination chain requires some state from mainnet, they can come in and request that. And so for that one, spot makes a lot of sense, because then you're serving sort of spiky demand with spot instances without impacting your baseline capacity. And you might even be able to service those requests with your baseline capacity if you're not generating one of those proofs during that period anyway. So that's another consideration there. So that's it for Spot. I want to talk about serverless ZKPs for a second. And this is something that hasn't been tested or tried, but it's from talking to one of those ZK projects, they mentioned that they were starting to look at this. If you're not familiar with serverless, you can think of it as code that runs on an event, and then it just winds down. So there's no servers, there's no instances. Well, there are, but we manage all the servers and instances. So for you, all you do is you deal with the code, and then we run your code for you, and it shuts down. So it's great. Lambdas are used all over the place. They connect many services together. They're used in data transformation and API handling and all that stuff. But there's a lot of restrictions here. And so this may not work for everyone, but it's worth sharing here. So the first thing is you can't create a custom AMI, right? So all that we talked about of creating your own image with the utilities and the binaries and all that stuff, you can't create that as an AMI. And also, this requires running a runtime. So instead of starting with an OS, you're actually doing a runtime. So by default, we have all the popular runtimes. We have Node.js, Python, Java, several others. But you can also provide your own runtime as well. There's this thing called Lambda layers that are basically, you can think of them as static artifacts that your Lambda can access. And those are a 1/4 gig each, and you can have up to 5 of those. And so those utilities and other things which we talked about, you can actually put those in the Lambda layer. So you have about 1 gig of artifacts which your Lambda can access at the time which it spins up. And then locally, you have 10 gigabytes of file storage. So if your proving key falls within that range, then you might be able to actually do this here. And for using additional storage, you can use Elastic File System, which is a network file system, and that can be your persistence for your proving key, or you can download it from S3. So if you're actually able to run your proof using a proving key that's on a network file system, this could actually work really well, because you no longer have to take that hit of downloading the 10 gigabyte proving key or whatever to your local file system. Last thing here, some Spot tool sets, things to help you get started. The first one is blueprints. 5 more minutes? Okay, I thought it was a bit short. Yeah, Spot blueprints that provide a great way to get started with your Spot. And then the last one I want to point out is the fault injection simulator. And so what this helps you do is simulate getting that interrupt alert. So if you want to test your Spot instance with getting that interruption and being able to test that, that will help you with that. And that's it. Thank you.